All right, so I have this first file from Box downloaded. If we look at the PDF, it starts by having us extrude a body around the speakers. And specifically here, it's having it start with an offset of 0.05. And this will be clear in a minute. Or on page 2, this offset will hopefully make a little more sense. Let's see if I can get both of these to display at the same time on my screen here. Might be a bit tiny on this right side. There we go. All right, so the master sketch is given to us. So step 1, we're going to create a new plane or a new sketch on the front plane. So you can either go up here to sketch. Let me make sure I'm fully on the screen. It looks like I'm a little bit off. And with the front plane selected, I can click on sketch here, or you can do Alt plus S for sketch to create a new sketch. I'm now going to click on the master and click on convert entities to get this to copy over. And now that I have my sketch, I'm just going to extrude this body. So I'm going to go back to features here and click on extruded boss base. Now if we look at this, you can see it's kind of going the wrong direction right now. So a couple things, one at a time. In the from dialog, and I want to remind you all of this because some people I think are forgetting that this is an option in extrudes, is you don't have to extrude from the sketch plane. So this is another reason why you don't need to necessarily create planes on other faces. You can simply click on offset, or you can click on vertex and select a vertex from your master sketch. In this case, I'm going to click offset and just type in 0.05. Now, again, what's critical in SOLIDWORKS is like going in the direction you want to go. So you'll notice that this popped it forwards. I actually want this to go back, so I'm going to click on this here. So in the direction of the extrude, which is shown here on the sheet, we're extruding backwards. So you offset it in the direction of the extrude. And again, you do that by clicking on this icon right here. And same thing, the extrude is going forward still. We want it to go backwards. I'm going to first type in the distance here. So for the direction one, it's a blind direction. I'm going to type 2.5 for inches. And again, to flip the direction, I can either drag this arrow back, or again, you can click on this arrow here, this arrow icon, and flip it. So now you can see the sketch. Here's the offset of 0.05. And then you can see the direction is 2.5 inches back this way. Now, this is new for today, so we're designing for manufacturing. We're adding draft, and this is a setting in the boss extrude command, the boss extrude feature. So this is an important aspect of today's demo. Again, I want your final, at the very minimum, your final design to have draft. The 3 concepts don't necessarily need it. I would encourage it, but it's definitely needed for the final. So in order to add draft, you simply just click on this, and you can type in the amount you want. So this demo is asking you to put in 5 degrees of draft. And if I take like a side view here and play with this amount, 0, hopefully you can all see this yellow jump in and out if you're looking at my screen. Now the other critical thing with this setting is to make sure that merge bodies is not checked, and you can find that under direction 1 here. Do you see merge result? You want to make sure that that is not checked. This is very key for working on project 4, is managing this merge result feature, because if this is checked, this body would consume all of these components, and we don't want that. We want it to be hollow. So if you're like losing components or they're disappearing, it's probably because you're merging bodies when you don't want to do that. So I'm going to uncheck that and then check this box here. So now the next thing to do is to repeat this but go forwards. So again, I'm going to create a new front plane sketch. I'm going to select the front plane, go to sketch, and click on this. And now I can tell I'm in sketch world, because if I look at the top right here, there's the X in this exit. And once again, I'm going to select the master and then click on convert entities, or C for convert. And that will copy the sketch over. Now that I have the sketch, I'm ready to extrude it as shown in step number 4. So I'm going to click Extrude Boss Base. This time it's going in the right direction. So once again, I'm going to offset this extrusion by 0.05. So again, in from where I want the extrude to start, I'm going to select offset 0.05. And if I zoom in, hopefully I can do this again so you can see it jump. If I type in sketch plane, you can see it's going directly from the sketch. If I click offset, it jumps it forwards. And again, if you ever need to change the way it goes, you just click on this icon here. If we follow the settings here, we're extruding at 0.5 inches, half an inch. And again, we want some draft on here. So I'm going to click on this 5-degree draft. It's angled inwards slightly. Once again, we don't want it to merge result. We're going to uncheck this box. And now you can see we basically have a body around the speaker. Next up, we want to work intelligently, so we want to work in halves, so we don't have to repeat things more than once if we can avoid it. It makes our life a bit easier. So the way that this is suggesting to cut the object in half is simply selecting the right plane. And under features, is this under features or surface? Let me look. And I don't see surfaces up here. I realize that this is slightly, it is a feature. I'm going to expand this for a minute so that this PDF is going to disappear for a bit. So what you can do up here is, if you don't see it, the command we want, I already have it in my my small icons up here. Remember that you have this search bar up here. If for some reason it stops working, I noticed this the other day, you want to make sure you're searching commands and not files or models. So you want this icon, this like black box with an arrow. So on here I'm going to search cut. And you can see if you just search cut, it's the second option, at least for me, cut with surface. If it's not showing up, you can try typing in cut with, and it should come up. Once you see this icon, you can just simply click on it and drag it over to your command bar here. And you can see that this black line is kind of telling me where it's going to end up. So here I'm just dragging it off to the right. So if you don't have the cut with surface command, you can find it in the search bar up here. It's in the surfaces tab? Okay, cool, good to know. Yeah, I added this. Let me see if I can add the surfaces tab in here. I don't need these ones. Oh yeah, okay. If you don't have the surfaces tab in your command manager, if you simply right click on it, you can check and uncheck things. So I don't need any of these like SolidWorks CAM stuff. This is all like analysis. Evaluate might be helpful, but you can check surfaces. And here it is, cut with surface off to the right. Thank you for that, Sarin. Or you can put it here, as I showed you, if you can't find it. So what the demo asks us to do is to select the right plane. Or actually, no, let's just go ahead and load that cut with surface command. I'll just click on this. And it's basically asking us, again, highlighted in blue here is, hey, what surface do you want to cut with? So I expand my tree here, and I just simply select the right plane. And now once again, you can see there's a little arrow in here, or I hope you can see that. And it's cutting in one direction or the other. So in this case, this is fine. I'm happy for it to cut to the left. Again, if you need to swap which way this arrow faces, it's clicking this icon. And here, once again, in the feature scope, you want to manage what's cut. And this is, again, this is what's kind of new and different for Project 4 is managing what is cut. You don't want to cut the components by accident. So instead of auto-selecting this, I'm going to click in this box, and I'm just going to select both of these bodies here, both the back body and this front plate, and I'm going to click this checkbox. And now you can see we cut half the bodies. So now as we work on this detailed part line, we only have to do half of it. We don't have to do all of it. And we will end by mirroring the object. Step 6 asks you to fillet the object. We're doing this now because we want to have the fillets be part of the shell. You don't have to follow the fillets exactly. I think it's asking to make the bottom corners at 0.5 inches. It's totally up to you. It's completely arbitrary what these are filleted at. And then I think it's asking the front fillet to be a 1/4 inch. This front fillet and this back fillet. So again, at this point, this is where I believe the second file on Box is given to you. It's given to you at this stage. The main key, the main takeaway from this first page is looking at these edit features and making sure you do not have merge result checked and making sure that you're building this in with draft. It is worth mentioning that the way this is approached, you'll notice that we extrude it as a complete body first and then cut it in half. As a side note, let me show you what it would look like if we just extruded half of it to begin with. So if I take the master here and I copy it, and then let's say I want to just save a step and chop and just extrude it in half to begin with. The issue here is if I put draft on this, do you see it puts draft on this inside face as well? Right, so if I match this distance, 2.5, so these faces are all the same, and that's good. This interface is also drafted. So now if I continue with my build and then I get to the end of my tree and I go to mirror this, oops, not shell, sorry. I go to mirror it. You can see that there would be an error in the mirror because of that draft. For what it's worth, if you want to build in this way that I have shown here, it's better to not have this draft be part of the extrude feature. For what it's worth, it's good to know that or I would like you to know, that there is actually a draft feature command that acts independent of the extrusion. So in this case, you could select the draft command. Here it's asking where the part line is. So like this face, like that's the way I interpret this. This neutral plane is asking where's the part going to be split. And in this case, the faces to draft are only these 3. You don't want to select the interface, the inside face. Again, we can type this into 5. I'll be honest, I always forget what this arrow is indicating. I think it indicates the way it exits the mold. Nope, I was wrong. The arrow indicates, I guess, the opposite of that. It indicates the base of the mold. So if we want this, if you'll notice the arrow is pointing down, if I click this checkbox, you'll see that the object flares out, which is not what we want. The opening of the object is here. Honestly, when I mess with this, because I always forget, I just click the checkbox, I see what happens. If it's not the way I wanted it, I flip this. It's kind of lazy that I haven't memorized that. But this is a way to draft only partial faces, not all of them. So I do want to explain that nuance. Does that make sense to everybody? All right, cool. All right. Moving right along here, page 2. So again, as long as you understand that built-in draft in the feature, extrude feature command, the offset, that's the main takeaway from page 1. I don't mind skipping over that if you want to start from page 2 here. So page 2 starts to get into some details for your objects, or just some suggestions on like how you could make your object be a little bit more detailed if you would like. So it asks you, let's see, it says new front plane sketch and switch to hidden line views. So to switch to hidden line views, at the top here in display style, we click on this. So now we can see what the inside looks like. It asks you to create a new sketch on the front plane. You'll notice that this is intentional. The way that I have asked that we approach this is to use this front plane as our part line. So this is one way to approach your builds, is use the top plane, the front plane, or the right plane as kind of the splitting plane for your object for how it's molded. And I'll show you why that's important a little bit later. It's just kind of a useful approach. For now, you can take it at that. So I'm going to create a new sketch on this front plane, following what this demo is saying, and it's asking to create 2 circles. It doesn't really matter where it asks that they're created somewhere within the slot of this speaker. And again, here at the bottom, and again, because we've cut it in half now, we only have to do 2 of them. If this speaker was symmetric top and bottom, you could even argue to build this in quarters, but because I have it as this kind of like graveyard stone shape, obviously it's asymmetrical top to bottom. Now, we can link the size of both of these by selecting both of them. So I just held down Shift, I click both of them, and I say equal. I then hit D for dimension, smart dimension up here. And whoops, if I hover over it till it turns yellow and click on one of these, I can make the dimension 0.2. Again, somewhat arbitrary for this demo. And now what we're going to do is we're now going to create a cut with a draft. So here's our sketch. The sketch is done. While we're still within Sketch World, we immediately go to the feature command here and click on extruded cut. And we can now match some of these settings. So for example, instead of doing blind, I recommend doing through all. This makes your Jenga tower more robust. So like if your object grows longer on your redesign or based on feedback, the cut will always go all the way through it. Now here you want to click again on draft. And let's see. Now the reason why it's asking you to draft outwards is because the way that this draft feature works by default is it will always, even if it's a cut, as the extrude travels in space, it will always get more narrow by default. So if you click on draft outward, it will actually widen the cut. I think if I go away from this hidden visible line view, okay, it's not doing it. Sometimes SOLIDWORKS will show the draft opening and closing as you change those settings. I don't know if it might just be a resource setting that I have where it's not showing that to make my computer run faster. But basically the settings you want here is through all. You want draft outward checked. And I believe the draft here is set to 3 degrees. I mean, these are, again, this is all kind of arbitrary. Now, once again, this is important because here you are cutting things away. Under feature scope, so please, if you're doing other things, pay attention for this minute. Remember that merge result nuance that I mentioned with positive extrusions. If you're doing an extrude cut, this is also important. You want to look at feature scope and uncheck this auto select because this is how you tell what is cut. So this is, again, very important for working with components. If you left this on auto select, these circles would also cut away at any components that they pass through. So in this case, we only want this to pass through the back body here. So that's why I uncheck auto select in feature scope and select the back body. And now here hopefully you can see with these dotted lines how the extrusion gets wider towards the back. And that's again because if we edit this setting again, it's because we checked draft outwards. That feature scope is important also for merging bodies. If you did want to merge a result here, I told you to uncheck this. Let's say it is merged. You always want to look at this feature scope. You can select specifically what is merged together within here. If you leave it to auto select, anything that the extrusion touches will get merged. So please pay attention to these nuances as you're working with components in SOLIDWORKS. All right. Let me switch back to regular view here. So what we created, and this will be more clear in a minute, but we basically created representational mounting points for the speaker. The next thing it asks you to do is to right-click on this back body and say isolate. This is something new for workflow that I haven't introduced yet. By right-clicking on a body and selecting isolate, it automatically, you'll notice here in my tree, you can see it hides everything except for that body. So if you're ever working on something complex and there's a lot of like parts to deal with and look at, if you right click on the one object you want to work on and click isolate, it will hide everything else. The nice thing it does also is it gives you this little pop-up that whenever you're done doing the work, you click on exit isolate and it will show everything again. So we hide everything else. We click on shell in our feature tree up here. And if you recall, I don't know if I've talked about shell in any detail, but shell will make an object hollow. So here we're clicking on this this face that's facing forwards and this face that's facing to the left. And I believe it asks you to shell to 0.1 inches, which is the default. And I'm going to check that box. And here you can see what shell does. It's a very powerful tool, saves you a lot of time. And this is why we put the fillets in first, is so that the shell would take into account the fillets. Now if I click exit isolate, you can see now we have, this is what's known as a boss in manufacturing. Bosses are basically donuts that are molded into the body of the plastic. Bosses are used for two reasons. They're used for structure and they're also used for mounting. So if you look at any plastic object, a lot of them have bosses that are visible from the back of the object because often this is where like a screw will go in. And these bosses will be used to join the front body to the back body. In this case, we're using it to represent how the speaker might be mounted. Now, to be absolutely clear, on Project 4, details like this boss are not required. It's optional, but it's not required. I do ask, however, that your internal components are shelled. Shelling is important. It'll be important for showing the section views when we get into KeyShot, having it shelled. Because you can imagine if this is a solid body and then these components are sitting in that solid body, the rendering won't communicate well if you leave this body solid. We now repeat this exact same process on this front face. So again, I'm going to right click on this and say isolate. I believe command click on a Mac, but I'm assuming you all have mice with right clicks for SolidWorks. Once again, we're going to shell the same thing. So we're just going to click on shell, click on these two faces, and click check this box. And once again, now exit isolate. So now we have our basic speaker. We have our front face and our back face, and they're both shelled properly, just by nature of the shell command. Now this is the important aspect, which is the kind of detailed part line, and this is what I'm requesting on your final concept of Project 4. Again, it's not necessary for the 3 initial concepts, unless you are doing an initial concept in place of this demo. If you choose to not do this demo and instead just build one of your concepts, I can understand that from a efficiency standpoint. I do ask though on that concept that you build in a part line as I am about to show you here. Okay. For what it's worth, if it is your own concept, this is planning ahead for that part line by doing this offset extrude like this. You could always come in and make this gap here. This is a 0.1 inch gap. You can do this as an extruded cut from the side. I'll show you what that might look like. From a right plane, Alt-S to create the sketch. Imagine that these are touching. You could just simply, sketch a rectangle in here that's about that width and just cut through everything to get that gap. Again, if it's your own work in your own concept. Okay, so now that this is shelled, once again, we're going to right click on this and say isolate. So this is another reminder to you all. You can create sketches on faces of the object if the face is flat. And in fact, I recommend that. It can make your life easier. And especially for something like this, for this part line. If you want to create planes, I would do that from the master sketch. I would not create a plane literally based on this face because that's an extra step that's not necessary. If you are inserting a new plane based on this face, you may as well just sketch directly on the face. I can understand creating a new plane if like this face is curved, or if you want to tie it to the master sketch, I can understand that. So what I'm going to do is I'm going to select this face here. I'm going to go to the Sketch tab and click on Sketch. And now I'm in Sketch World. We can see this up here. And so I'm going to create a new sketch on this face. And what I'm simply going to do is create a sketch based on this inner edge. And one way I can quickly do that is I can right-click on this inner edge, and I can click on Select Tangency. And you'll notice that it makes all of this blue on the inside. And now I can simply click on Convert Entities. So this may be new. Convert Entities can copy edges. It's not only for copying sketches. It can copy just about anything that can be translated into a sketch can be converted. You can convert faces, and it will bring it in as a closed shape. So again, just to repeat this, you could also like select on each of these edges and hold down Control to select multiple edges. But again, the quickest way to do it is to right-click on one edge and say Select Tangency. This is the other reason why it's important in your builds to make sure you're building with tangency built in. Obviously, if there was like a slight corner here, this Select Tangency would stop when it hit that corner. It wouldn't go all the way around. So again, here we go. It's highlighted, Convert Entities. So now what we're going to do is go to Extrude, and we're using an Extrude Thin feature here. My SolidWorks recognized it immediately. You can see this checkbox. There's a chance you may get a pop-up that says, hey, your sketch is open. It's not a closed shape, and it may ask you, do you want to close it? The answer to that question is no, you do not want to close it. And you want to make sure this thin feature is checked. Again, for me, it's grayed out. It recognized it immediately and just put it in automatically. Now, one thing you want to look at is which way the thin is going. It could go to the inside, or it could go to the outside. Obviously, we want this to be part of the bottom. This bottom body that we can see is visible. So we want it to go to the outside. If it was going to the inside, it would be this kind of weird floating plastic piece, that's barely touching at a corner. So just make sure it's going in the right direction. And then I believe it asks you to extrude this. What is the thin feature? It's set to 0.04, which is 1 millimeter. So there you go. So this is 0.04 wide, 1 millimeter wide. And then as far as the direction goes, we just want this to be 0.1 tall. Now some of these settings are important. This 0.1 tall is closing the gap in the part line. And again here this is where that merge result becomes important. So a couple things here. One, because we're in isolation mode, this auto select will ignore all the other bodies because they are hidden. That's just the way SolidWorks is designed. So if bodies are hidden, I believe typically this auto select will ignore any hidden bodies. For me, I like to just be absolutely sure and avoid making mistakes. So I always uncheck auto select and I just select specifically what I want. So in this case, we do want this part line to be part of this body. So that's why I'm selecting it. Again, these nuances are incredibly important. I realize, these long demos might be a bit dry, but they are important to understand how an object is designed and then how to go about working around them. Things like this, these are opportunities for me to take off points. If you're not listening or you're not paying attention to, having this part line merge to this body, if there's just like a part, this kind of extruded part line that's kind of floating in space, it's an opportunity to take off points. Okay, I'm realizing I haven't really talked in detail about this part line. It'll make more sense when this demo is done. So this is how part lines are handled on real products. If I didn't consider this, I should have. I should have had an object taken apart and ready to show you. I can maybe pull one up during a break and we can look at it. But again, this is how you build a real part line into an object that's getting manufactured. So, and again, that's what Project 4 is. We're getting closer and closer to realism in product design. So we have this thin feature. It's going up by 0.1 inches. We're making sure it's only merged with the bottom body, and now we're just going to go ahead and click that checkbox. This part line has no draft on it. Just have it go straight up. in real life, it would probably have a draft on this inside face. But for the sake of this demo, this is close enough as far as I'm concerned. Once you have this in, you can go ahead and click Exit Isolate, and now you can see that the part line is starting to be closed off, or has been closed off. But again, to be a real simulation of what a realistic part line looks like, we're now going to add a similar wall, this kind of thin wall. We're going to add it to this front piece. So the page asks you to right-click on this and say Isolate on the front shape. Same thing, we're going to select this face and create a sketch on it. And just like before, we're going to select tangency. So this is also an important nuance. On that bottom piece, we selected the inner edge. On this top piece, we're going to select this outer edge. So I'm going to select this and say Select Tangency. I'm going to convert entities on that one. Again, you can select individual edges if for some reason the select tangency doesn't work for your design. And then again, I'm going to go back to Features and click on Extrude. Again, my SolidWorks recognized that it's going to be a thin feature. It remembered my settings from last time as 0.04. But this one, we're only going to extrude at 0.05. We're not going to extrude it a full 1.1 inches. And once again here, we do want it to be merged, but we only want it to merge with this front body. So I'm going to uncheck this and click on it. Good question, Mireya. I'll show you in a minute why this one is shorter. It will be helpful for my explanation to show both files. So this one is extruded shorter. I'll show you why in a minute. It's also extruded on the outside face, not the inside. And we want to merge this part line feature only with the front. So I'm going to click now on the check mark. And now I'm going to click on Exit Isolate. If you have an object that you have ever taken apart or look at it carefully, most part lines are designed this way. Okay, so this is a bit of a deep dive. This is a little bit of materials and methods or materials and manufacturing in this class. Part lines are designed this way for a couple reasons. So one, the reason why one goes to the inside and one goes to the outside is this way it's kind of a secure puzzle connection. If you imagine, once we mirror this, imagine taking this back piece and trying to slide it left and right. This outside wall is going to capture that, and it's going to prevent it from sliding apart. So that is a way to secure the attachment. If we then have like a boss or a screw that screws the back plate to the front plate or the back body to the front body, this kind of puzzling feature of having the outside wall trap the inside wall will help add to the strength of the object. I'll be perfectly honest with you all. As far as like design students and your design career goes, this level of nuance probably won't matter. Like I would imagine you will encounter this at some point in your career if you go down the product design path. You may be requested to build a part designed for manufacturing, in which case draft is really the most important thing and determining where the part line is. But there may be a case where you need to have a detailed part line and build in some of these features, depending on where you work and who your client is. Now, the reason why I'm putting it in this class is I personally believe that if you have some level of detail like this in your portfolio and you're able to show a level of understanding of this nuanced manufacturing, I believe that it reflects on you well. It's just a level of not only that, but again, the way this class was initially designed and talked about is getting realistic looking details. So that's really, I guess, really where I should have started is like, if you have a part line that's rendered like this, where there's a slight gap, where there's a wall set in here, where maybe in some views you may even see the slight gap here, it's going to make your object look like a real product. And that's really the main goal here is making pretty renderings and having them look believable and realistic. But the truth of it is the way to get a believable render is to design it as it would actually be made, and that knowledge is also useful. I still haven't answered your question, Mireya. The reason why this one is shorter than this one. So I explained why one's inside, one's outside. It's to trap them. This is, again, we're putting back on our materials and methods hat here. The reason why one is shorter is, believe it or not, when you injection mold an object, there is still room for error and variability. If you imagine back to my example of baking a cake or baking muffins, they don't all come out the exact same size. Some of them shrink. Objects are bigger when they're hot, they're smaller when they cool. So all of these variables in terms of temperature, in terms of the amount of plastic, it can cause slightly different imperfections. And so there's something in manufacturing called tolerance. I can write this out on my whiteboard here. So tolerance is the reason why there's a gap there. So in our part line here, this gap is for tolerance, and that is so that the one thing that what designers can control is by making one always longer than the other, even if this through tolerance or imperfection, even if this ends up shorter and this ends up longer, they know what the acceptable level of tolerance is always, so that even in worst case scenario, in a worst case scenario, then with tolerance happens within a range, and often I believe a tolerance is plus or minus like a millimeter, or even it might even be half a millimeter. I forget now. It's been a while since I've had to work with tolerance. Basically, it's designing for molding imperfections, and by leaving this gap here and knowing what this acceptable tolerance is, even in a worst case scenario, there will always be a gap here, or maybe worst case scenario is they will actually touch. And the reason for that is if you don't build that gap in, you then may end up with some objects where the outside is shouldering the burden of holding them together. And sometimes that's not ideal. You basically always want to know which two faces will be touching and interfacing on an object that you design. This is definitely down the rabbit hole here. It's good to know. It's good to be aware of. If it's a little confusing, I wouldn't worry too much about it. Again, it's all in the name of making a realistic looking product and render is the main goal here. But I do believe this knowledge is helpful for understanding how things are made. I don't know if that answer was clear enough for you, Maria. Does that make sense? Why the outside is shorter? Okay. Again, it's basically the designer, the engineer, it's making sure that this is always touching, because this will be important for like how it attaches and stuff. If there's ever a chance that these two will touch, it could like negatively impact the design. All right. To complete the demo, it's basically just mirroring these. So I'll just do that here, and then we can take a break. So selecting the right plane here, I'm going to go ahead and click on the mirror feature. Now, again, I do always recommend using the bodies mirror command whenever possible, as opposed to features. So it may load like this. Don't forget you have bodies down here, so you could hide this one and expand bodies to mirror. In this case, I think you could actually do it in one command. I think you can select both and check merge solids. I'm going to check this now. I'm pretty sure when you merge solids in a mirror, it only merges the solids that are touching each other. And because, I guess, yeah, SolidWorks used to not be this smart. It sometimes, I think in the past, it would have merged like the front face with the back face too, but in this case, it didn't. And basically, there you have it. This is a very basic speaker component. I do later, after the break, want to build on some of these things. If I just use some basic move body commands here, we'll have a whole class on exploded views and talk about that. But here you can see roughly how this comes together. Again, having a part line and maybe some bosses in your work can go a long way. Again, to be absolutely clear, and for Project 4, bosses are not required. This level of detail of part line is only required on your final, or for homework if you would like to build in this kind of part line into one of your existing concepts or ones that you're working on. I just ask that you build this kind of like basically cut a 0.1 inch gap between your front and back pieces. On one piece, extrude a thin wall to the inside that's taller. On the other piece, extrude a thin wall to the outside that's shorter. And that's basically required. Are we able to draw a new part on an assembly? I'm not entirely sure what you mean by that. Yeah, sorry, Bryce, I don't understand your question. I don't know if you want to hop on the mic or type out a more detailed explanation.
So for drawing on an assembly, I guess I'm confused on how you're doing this right now. Did you like compress the file of an assembly of the speaker into something that you can edit?
Yes, good question. So if you recall, I believe it was a week ago today, that class, and I can probably still pull it up, it was how to work with guts in SolidWorks. Let me see if I have it here. No, I'm not organized. I apologize. Yeah, the short of it is, to answer your question directly, the way that I started this file, I set all of this up in an assembly, and then I saved the assembly out as a part file. So now this is a part file I'm working in. If I open up, what I can do maybe is open up the previous parts. Oh, it's in here. My bad. I was looking in the wrong folder. So let me pull this up. I don't know if you remember this demo. For working with parts in SolidWorks or designing around guts in SolidWorks, basically we started by importing all of these. You can see here is a screen grab of my assembly, excuse me, with all the 3 parts in here. And then you save it out, save as part file. And then when you open it up, here's what it looks like open in the part file. It has all of these kind of imported body icons. I hope that answers your question. So basically, if we look at what I have here where I started, you can see it's all these imported bodies from an assembly. And my reasoning for this is my personal workflow, this is how I concept around components in SolidWorks. That way, it's all kind of in one place. It's not pointing at anything else. It does add to a bit of confusion, like I've been emphasizing to not merge the results. If you would like to build a part around components in an assembly, you can do that workflow. I personally think that's a little bit more complicated because you have to keep jumping back and forth between the part. Well, I guess that's not true. Because you can be in an assembly and right-click the part and say edit part and build within the assembly. I believe it's a little bit more taxing on your computer. But that if you prefer that other workflow, that's cool too. So you can build a part, put it into an assembly with the components, and then once you're in the assembly, you can right-click on that and say edit. And maybe I can set that up during the break to show you all what that looks like. I don't know if that answered your question. Okay. Yeah, basically I'm working within a part. I set up the part as shown from last Wednesday's demo. If you need a refresher on that, there is a video on YouTube, or you can go into Blackboard and look at the recording. All right, are there any other questions on any of this? Yeah, I'm realizing that this kind of, remote demo with picturing how you all are engaging with this on a laptop with one screen. I'm realizing now it's not realistic of me to expect you to like work on this at the same time as I'm working. So we'll give some class time to work on this demo, or again, if you would prefer to work on one of your own components for project 4, I'm assuming the majority of you will do that. and I can understand that from an efficiency standpoint. Again, I just ask that you kind of build in this part line. The good news I could say is that if you take that time to do it on one concept, you could translate that concept to be your final, or at least you'll learn how to do it, and you can use that then for your, use that file as a reference for your final later down the road. There is a couple more things I want to talk about with this, but I feel like it's already been a long lecture, so let's take a 15-minute break. Be back at 2:40, and I'll give a little bit of class time. I'll probably actually, let's do this. Between now and 3 will be class time to work on this demo. I'll be around to help if you have individual questions as best I can. You can always send me screen grabs. I can try and Google if you're able to share screen, because I'm actually not sure if that's possible within Blackboard. But again, you can also use this time to work on project 4 if you would like. At 3, I will come back to this file and talk about some details. But also, yeah, feel free to, whatever, take a 15-minute break sometime between now and 3, but this is time to work on the demo. Reach out with any questions. They can also be individual questions. They don't have to be specific to the demo. If you want feedback on project 4, this is like in-class work time as far as I'm concerned.